x squared plus y squared minus 4x plus 6y equal 87. It says a line has an equation x plus y plus 1 equals 0. Show that the line passes through the center of the circle. Now, to show that the line passes through the center of the circle, then that means that the equation of the line, well, that means we can show this. To show that the line passes through the center of the circle, so what that means is, this is a circle, all right? Let's say this is the center, all right? If a line passes through the center of the circle, it means many things, all right? But most importantly, what it means that is that whatever the point is at the center, that point will satisfy the equation of the line. So the point right here will satisfy the equation of the line. So that's one way of showing that the line passes through the center of the circle. All right, so we just need to show that the equation of the, we need to show that the center, whatever the center is, it will satisfy the equation of the line. All right, so let's do that. So first and foremost, I'm going to rewrite this as x squared minus 4x. We're going to rewrite it as x squared minus 4x. I'm just grouping the x terms plus y squared plus 6y. And that's equal to 87. By grouping them like this, it is easy for us to find the equation of the center, the equation of the circle in standard form, because now we can complete the square to say that this part becomes x minus 2 all square, and we subtract 2 square, which is subtracting 4, plus we complete the square for the two y terms to get y plus 3 square, and then we subtract 3 square, which is subtracting 9, and that's equal to 87. Now, as you can clearly see, if we were to put this in its actual standard form, the equation of the circle in reality is actually x minus 2 all square plus y plus 3 all square is equal to 100. Because minus 4 minus 7 is minus 13, and when we bring over minus 13, that's just equal to 100. All right, so now we have the center of the circle and the radius. All right, we have the center of the circle and the radius. All right, so now we can tell them that the center of the circle is 2, -3. That's the center of the circle, 2, -3. So now we can answer the question. So if the line passes through the center of the circle, then the coordinates of the center satisfies the equation of the line. All right, so let's test it out. The equation of the line is x plus y plus x plus y plus 1 equals 0. So let's test it out. Let's test out if that is true. Let's test out if that is true. So that implies when we substitute x as 2 plus y as minus 3 plus 1, it's equal to 0. So yes. So we can conclude, yes, the line passes through the center. So the line does pass through the center of the circle. So we're finished with that now. Nice and easy. Now let's look at the second part. It says, find the equation of the tangent to the circle at the point A, which is -6, 3. Now we know the center, and we said that the center is, I like to have a sketch. The sketch is always good. All right, so looking at this, this is the point 2, -3. 2, -3. So if this is 2, -3, all right, so our x value to -3. So an x value of -6, let me put it in green. If this is 2, then -6 is over here. And then +3 would be here. So based on my sketch, then right here is where the point A is. A is somewhere right here. All right. A is somewhere right here. And then this is the tangent. All right. This is the tangent. And we need to find the equation of this tangent right here. So now the only way we can find the equation of the tangent is the normal has to come into play. What is the normal? The normal is a line that's going to be perpendicular to the tangent line. All right, the normal is perpendicular to the tangent, and the normal passes through the point A, and it also passes through the center of the circle. So this is the normal. I'm going to use N for normal and T for tangent. All right, so first we need to find is the gradient of the normal. All right, so let's do that somewhere up here. The gradient of the normal is going to be equal to the y value at N, the y value at A, and the y value at A is 3, y2 minus y1, y1 is -3, so it's 3 minus -3, y2 minus y1 over x2, which is -6, x2 minus x1. All right, so it's y2 minus y1 over x2 minus x1. All right, and so what are we getting for the gradient of the normal? The gradient of the normal is 3 minus 3 is 6. That works out to be 6 over -8. So if the gradient of the normal is 6 over -8, which is really -3 over 4, then the gradient of the tangent is 4 over 3. All right, as you can see from this graph or sketch is accurate, the gradient is 4 over 3. So let's write that down then. So yes, so the gradient of the tangent is equal to 4 over 3. And so what's going to be the equation of the tangent? The equation of the tangent then is going to be, so let me write part 2, just so we know. The equation of the tangent is going to be y minus yp, and the y value is going to be 3. So it's y minus 3 is equal to the gradient of the tangent of 4 over 3 into multiplied by x minus 6. So I can just write x plus 6. Now, depending on the question, they didn't ask us to put it in standard form, so I'm going to leave it at that. So that's the equation of the tangent. If you want, you can put it in standard form, but they didn't ask us to do that. So this is where I would leave it, all right? That's where I would leave it. Just to finish the question, I would say this is the equation of the tangent, all right? I wouldn't be trying to simplify it any further because I didn't say to put it in standard form. So you can stop there if you want. Now the next part, part B, is the vectors part of the question. So we've dealt with the coordinate geometry of the question. Now we're going to be looking at the vectors aspect of it. It says, given OA is equal to A, OB is B, and AP is a half OA. And guys, I don't like that AP being a half OA because they give us OA and they give us OB. I want to know what is OP. So they told us that AP is equal to a half OA. So what they're telling us is that AP is equal to a half A. This is what they're virtually saying. AP is a half A. All right. Now, if AP is a half A, AP is really OP minus OA. OP minus OA is AP. OP minus OA. OP minus OA is AP. And so that's equal to a half A. So now if we add OA to both sides, that will then tell us that OP, vector OP is equal to, now remember OA is just A. So it's a half A plus A. And so vector OP is 3 over 2A. All right, vector OP is 3 over 2A because OA right here, remember OA is just A. Set it on the paper, OA is A. So that's OP, 3 over 2A. So first it says, write what is vector BP. So let's write down vector BP. Vector BP, it's vector of the last minus the vector of the first. So vector BP is OP minus OB. But we already know what is OP. OP, as I said, is 3 over 2A. So we can write that BP is 3 over 2A plus minus OB, and OB is just B. All right, so 3 over 2A minus B. Then the next part of the question says, find the magnitude of vector BP, the second part of the question. So in order to find the magnitude of vector BP, we need to expand out what that is. So vector BP, first and foremost, is just 3 over 2A. So it's 3 over 2A, but vector A is 2, 1. Vector A is 2, 1. So this is really 3 over 2 times 2, 1 minus vector B. And vector B is 3, 2. So when we work that out now, it's going to be now 3 over 2 times 2. That's what? 3 over 2 times 2, that's 3. And then 3 over 2 times 1 is just same 3 over 2. I'm going to write it as 1.5. It's easier for me to do calculations that way. Minus 3, 2. All right. Now 3 minus 3 is 0. And then 1.5 minus 2 is minus a half. And that gives us vector BP. Once you get to here, that's vector BP. So now you can find the norm of vector BP. That's what the sign means. It means norm. The norm of vector BP is going to be equal to the square root of 0 square plus 0.5 square. All right, that's how we find vector norms or the magnitude. All right, so when you work this out, 0.5 square is a quarter. When you square root a quarter, you get back a half. And so the norm of vector BP is a half. That's the length. Nice and easy. Soft. That takes care of question 3. Question 3, no trouble at all. So we did vectors and we did coordinate geometry. Now question 4 is going to include trigonometry. That's going to be question 4. Question 4 will be trigonometry. So let's go ahead and knock ourselves out with trigonometry. So question 4, it's telling us that the diagram shows a sector of a circle O with an adjoining square. The radius is 4 meters. It says if the sector OAC subtends at an angle pi by 3 at O, calculate, giving your answer in terms of pi, the area of the shape OACMN. In order to find the area of that weird looking shape, we have to notice that that shape consists of a sector. It consists of a sector and a square. So the area of the shape is going to be the area of the sector. So I'm going to call the shape S. Area of S. Area of S is going to be equal to the area of the square part plus the area of the sector. Area of the sector. How can I write sector? I'm going to write sec. All right. Now this is part 1. Now the area of the square is going to be length times width, which is 4 times 4, so it's 4 square, plus the area of the sector. Now there are 2 ways to find area of sector. In Csec mathematics, you'd have learned theta over 360 times pi r squared. All right, so if you like that formula, you can stick to it. It's theta over 360 times pi r squared. All right, and the theta that they give us is pi by 3. So for those who like to do things Csec way, it would be theta over 360, but 360 in pi is really 2 pi. So it's pi by 3 over 2 pi times pi r squared. Pi times 4 squared. This is for those who like Csec math. So it's pi by 3 divided by 2 pi. I just really want to point this out as well, that pi by 3 divided by 2 pi, it should have been always looked at as pi by 3 multiplied by 1 over 2 pi. That's how you should see it. All right, and so the pi's in reality cancel, and it works out to be 1 over 6. All right, so this works out to be 16 plus, now pi by 3 over 2 pi, as I said, that's 1 over 6. That's 1 over 6 times 4 squared is 16, so it's 1 over 6 times 16 pi. Some people may want to simplify this and say 16 over 6 is, 16 over 6 is divided by 2, that's 8. 16 over 6, that's 8 over 3 pi. That's how some people might want to see it. All right, 16 plus 8 over 3 pi units square. Some persons might want to see it this way. 8 over 3 pi units square. Now the next part of the question says, find the perimeter of the shape. Now to find the perimeter, finding the perimeter is total distance around. So what does that mean? Total distance around will give you perimeter. All right, so if you have this weird looking shape right here, right, the perimeter is going to be this length plus this length plus this length plus this length plus this length. That's the perimeter. And so the perimeter of the shape, it's going to be equal to, all right, let's just label them. Call this side 1, 2, 3, 4, and 5. We need to add these 5 sides. So the perimeter is going to be the first side is the radius, which is 4, plus the length of the arc. Now the length of this arc is r times theta. That's how we find length of an arc. Length of an arc is r theta. All right, just to write down the formula. Length of an arc length, length of an arc, however you want to say it, it's equal to the radius r times theta. That's how we find length of an arc. If you don't want to use this formula, you can always use theta over 360 times 2 pi r. That will give you the same formula. It's theta over 360 times 2 pi r. So length of the arc is going to be r, which is 4 times theta, and theta is pi by 3. So it's plus 4 pi by 3 plus, we need to add this side, which is 4, this side, which is 4, and this side, which is 4, which is plus 3 times 4. And so the perimeter of the shape is going to be 4 times 3 times 4 is 12 plus 4 is 16. So this works out to be 16 plus, now this is just 4 pi by 3. 16 plus 4 pi by 3. Nice and easy. And perimeter is in meters. All right, nice and easy. No, I made a mistake right here. It shouldn't have been unit square. Since it's meters, it should have been meter square. So if you just want to correct that, you can write that area is meter square. That takes care of this part of the question. Nice and easy, soft. Now part 2, or part B. Part B is asking us, it says, given that sine pi by 3 is root 3 over 2, cos pi by 3 is 1 over 2, sine pi by 4 is cos pi by 4, which is root 2 over 2. Calculate the exact value of cos 7 pi over 12. All right, they give you 7 pi over 12. Now there are two things I want you to notice. 7 pi over 12. So I'm going to start with this. I'm going to start with this. 7 pi over 12. I'm starting with this. 7 pi over 12 is, this is the same as pi by 3 plus pi by 4. Yes, 7 pi by 12 is the same as pi by 3 plus pi by 4. If you were to find the LCM of these two, you would notice that 7 pi by 12 is the same as pi by 3 plus pi by 4. So you might ask me, so sir, what does that mean? What does that have to do with the question? So therefore, the cos, now you see what I'm getting at now, the cos of 7 pi by 12 is going to be equal to the cos of pi by 3 plus pi by 4. That's all they're doing. So the cos of 7 pi by 12 is equal to the cosine of pi by 3 plus pi by 4. That's all they are saying. That is all. Cos of 7 pi by 12 is the cos of pi by 3 plus pi by 4. Nice and easy. That's all they're saying. So since this is all that they're saying, we know that we can extend this now because we know that cos A, the cos of in bracket A plus B is equal to, we know that that is equal to cos minus sine. So we know that this is equal to the cos of pi by 3 times the cos of pi by 4 minus the sine of pi by 3 times the sine of pi by 4. All right, we know these formulas. We know all the double angle formulas, right? We know all of them. We know all the compound angles and all the double angle formulas. So that's all we're applying. All right, minus the sine of pi by 4. Nice and easy. So you have to go back through your trig ratios and your trig identities. Make sure you know all trig ratios, sine, cosine, tan. Make sure you know all the trig ratios for them. And you need to also know your trig identities. So let's finish this now. So cos pi by 3, they told us that cos pi by 3 is a half. So this works out to be a half times. Now then they're gonna have to give you cos pi by 4. Cos pi by 4 they say is root 2 over 2. So we have root 2 over 2 minus, they need to give me sine pi by 3. Sine pi by 3 is root 3 over 2. And then they need to give me sine pi by 4. And sine pi by 4 is also root 2 over 2. So this is what all of this is going to work out to be. Times root 2 over 2. Now, how are we going to finish work this out? To finish work this out now, we just have to say a half root 2 over 2. Now, 1 times root 2 is root 2. And then 2 times 2 is 4. So we get root 2 over 4 minus root 3 times root 2 is root 6 over 4. So that's the answer. Root 4 minus root 2 over 4 minus root 6 over 4. That's the answer. Nice and easy. Soft. If you want to simplify it, that's up to you. But I wouldn't. I would stop right there. I don't like to give away any extra time doing what they didn't ask for. That's the solution of part B. Then part C is asking us to do a proof. Part C is asking us to do a proof. So let's go ahead and do these proofs. Now, whenever you're given a proof to do, you always want to prove that your left-hand side is equal to your right-hand side. So many persons or many teachers teach this different, how to do proofs, but I always like to start with what is my left-hand side. My left-hand side that they give me is equivalent to 1 over sec theta plus tan theta. This is my left-hand side. 1 over sec theta plus tan theta. This is my left-hand side. All right. Now the first thing that should pop out to us is that sec theta is 1 over cos. And so what they're virtually telling me is that they have 1 over, you have to remember that sec theta is 1 over cos theta. That's the first thing is sec theta. Sec theta is 1 over cos theta. Plus, what is tan theta? Tan theta is sine theta over cos theta. All right? So this is what we have. Nice and easy. Now, remember what we are told from primary school. Whenever the denominators are the same, we should go ahead and add the powers. So we know that sec theta is 1 over cos. I know tan theta is sine over cos. So when we add them, this is what we're getting. What we're getting is 1 over 1 plus sine theta over cos theta. But look how I'm going to write it now. So it's 1 over 1 plus 1 over 1 plus sine theta over cos theta. So this is all in which we have. It is really sad, but To finish off this question now, what did they teach us? When you have A, when you have, what's the fraction I want to use? When you have A and it's being divided by some fraction B over C, it's the same as A multiplied by C divided by B. So you're saying, sir, what are you saying? What I'm saying is this fraction clearly is going to work out to be cos theta over 1 plus sine theta. But then you're going to say, sir, but that is way far from what we want to show. No, it is not. We're almost at our answer. We're at our destination. So all of that works out to be cos theta over 1 plus sine theta. Now, whenever you get to this stage, what I want you to do is you're going to multiply by the conjugate of the denominator. And you're going to be like, why would we do that, sir? Well, if we do that, look what's going to happen. Look at the magic. So this is what we have now. We have cos theta, and it's divided by 1 plus sine theta. So you might say, sir, why are we going to multiply by the conjugate of the denominator? Because if we multiply by the conjugate of the denominator, which is 1 minus sine theta, look what happens. When we multiply by the conjugate, 1 minus sine theta over 1 minus sine theta, look at the magic that happens. In the numerator will become cos theta times 1 minus sine theta. That's good. But then in the denominator, we have the difference of 2 squares. In the denominator, we have the difference of 2 squares. This is like a plus b times a minus b, which is a squared minus b squared. So the denominator is going to become 1 minus sine squared theta. Nice. 1 minus sine squared theta. Then in the numerator, it's going to be cos theta times 1 minus sine theta. And then you might say, sir, but I still don't see it yet. If you don't see it yet, what you need to do is go and wash your face and come back again. Because look, 1 minus sine square is what? Cos square. So what we end up get is cos theta. And cos theta is being multiplied by 1 minus sine theta. And all of this, of course, is being divided by cos square. Now you see it and you say, oh, I know. Now we get it. Because now the cos theta over cos square, cos is going to cancel. All right, cos is going to cancel. And so what this works out to be is cos theta over cos square, and that works out to be 1 minus sine theta over cos theta over cos square theta is just cos theta. And so now this will give us the right hand side. Nice and easy, soft. This takes care of the last part of question 4. And so now we move on to question 5. Question 5 is section 3. And section 3 has to do all with calculus. Section 3 has to do with calculus. So let's knock ourselves out.